My name is Luke Snatuvia.
I'm SVSM.
I'm Bell-Pritzlaff, and as Dr. Hart said, we'll be testing dissolution of multivitamins to verify riboflavin niacin using high-performance liquid chromatography.
So today we'll be talking about multivitamins in general, and then we'll be discussing the specific B vitamins we focus on in this experiment. And then we'll talk about the instruments we used and finish up with the results and discussion.
So, dietary supplements are growing more and more popular in America. Roughly 63% of the population uses some sort of dietary supplement, with multivitamins being the most popular. This is despite the fact that around 10% of the population has some sort of actual vitamin deficiency. So there's actually a lack of FDA regulation on multivitamins in general. They don't test to see the exact concentrations of certain vitamins. Rather, they just ensure that there are no adverse side effects once the dietary supplements go on the market. So we decided to test a generic and a brand name multivitamin, and they have the exact same number of labeled niacin and riboflavin, and they also have comparable vitamins elsewhere.
And as Luke said, the vitamins we decided to focus on are niacin and riboflavin, and this is the structure of niacin, and we specifically focused on niacinamide because there's two parts of the niacin chemical, and then riboflavin. And in the body, they're broken down into the coenzymes NAD, NADP, and FMN, and FAD. And coenzymes are organic substances that help proteins function. They're needed. And these proteins are involved in oxidation reactions or energy metabolism at the cellular level. So the reason why we're doing this experiment is because these vitamins need to be accurate on the label, because if there's a deficiency or an overdose, that causes complications. For example, niacin, if there's a deficiency, you have a condition known as pellagra, which causes swelling of the mouth, nasal cavity. Also, you can experience psychosis. And if you have too much niacin, it acts as a vasodilator, which causes flushing. Your blood vessels expand, and all the side effects incorporated with decreased blood pressure are present. And riboflavin, if there's a deficiency of that, then the iron in your body and your bloodstream won't be able to be used and converted by the body, so they're just free-floating iron, which can cause other complications such as diseases. But too much riboflavin isn't a bad thing because that's just excreted through urine. So that's why the labels need to be accurate for these two vitamins.
So to first test for vitamins, we needed to dissolve them in solution. So we used a pedal dissolution apparatus. So this is basically in vitro testing, which is in the lab. And it comprises of 6 vessels in which they are all heated by water bath, usually for our experiment at 37 degrees Celsius. And it's designed to provide 6 almost identical conditions, so that the only variable in there is the pill itself. And you have paddles that spin at 75 RPM for our experiment to help facilitate dissolution. And so we used 2 types of pills, the generic and the name brand. So we had 3 vessels for the generic brand and 3 vessels for the name brand. And we extracted the samples after 1 hour with a syringe and cannula.
And then after the samples were taken out of the dissolution apparatus, we needed to separate them through high-performance liquid chromatography, because all these vitamins absorb at the similar wavelength of 275 nanometers, and if we didn't put it through this machine, if we just put it straight to the UV detector, there'd be one massive absorption peak, because all the vitamins are stacked on top of each other and those peaks combine. But what high-performance liquid chromatography does, there's 2 solvents, acetonitrile and water. They go through a pump and pick up the injection sample, which was taken from the dissolution apparatus, and then they're moved. That's called the mobile phase, and then they're moved through a HPLC column. In the column for reverse phase liquid chromatography, what we used is nonpolar, while the solvents are polar. So the more polar the vitamin is, the faster it will elute through the HPLC column, while the more nonpolar it is, it'll stick to the column and take longer for it to move through. So that's why once it reaches the detector, there's individual peaks, so we can examine each multivitamin individually rather than having one massive absorption. As you can see here, this is how the peaks would appear at different retention times as they come through the machine.
So this is an example. This is a standard we ran. A standard is basically we took pure niacinamide and pure riboflavin and put it into our 0.1 molar HCl diluted, and we saw that using this we could tell where the niacinamide and the riboflavin are, and then we later used this to find the standard curve to help us solve for the masses of each multivitamins.
So using the absorbances gained from the standards, we ran 4 standard concentrations. We ran 12.5%, 25%, 50%, and 100%. And we found the absorbances for each riboflavin and niacin and plotted them in a scatter plot. And using some statistical analysis, we found a line of best fit. And using that model, we can create a ratio to find the concentrations of unknown samples.
So then this was an example of chromatogram from our dissolution apparatus. This was the first trial of multivitamin 1 and this first trial of multivitamin 2, and multivitamin 1 being the generic. And after we ran the standards, we were able to tell the retention times of niacinamide and riboflavin, so we knew what time they came out. And once we got those peaks, we were able to measure absorption, and that can be using this standard curve, absorption can be converted down to concentration.
So over here we took the averages of the absorptions of each 3 samples for both multivitamins and the time. And so using the ratio, we could find the concentration and then from there find the mass. The labeled claims for the niacin were 20 milligrams and 1.7 for riboflavin. And our multivitamins came out pretty much similar. There was 19.89 milligrams of niacin, and 2.5 milligrams of riboflavin, which is a lot more, and similar results for the multivitamin.
So multivitamin 1 and multivitamin 2 both had very accurate niacin, 99.5% and 98.7% accuracy respectively compared to the labeled amounts. And this is important because niacin does have issues with both overdoses and deficiencies. So it's very important that it's accurate. Riboflavin, on the other hand, was almost 50% over for both multivitamin 1 and 2. Now, this is not an issue because most of the excess riboflavin is just excreted through urine. And generic versus brand name, as you can see, there is not much difference. Both the niacin and riboflavin concentrations in both of the generic and the name brand are very similar.
And if we had more time in future experimentation, we'd use more standards. In the past one, we just used 12.5, 25, 50, and 100. We'd plot 6 points now to get a better line of best fit. We'd also do multiple dissolutions. We only had time to do 1, 3 of each pill, but we do multiple dissolutions, do more of each pill to eliminate sources of error. We do varying pHs to test how the pill dissolves in different body systems, such as the mouth, the stomach, and the small intestines. And in our experiment, we were only able to test the pills dissolving in the stomach. And we'd also do more multivitamin brands and types, because we only did 1 generic and 1 brand name, but we do more of each, and also more lots or more batches of each vitamin to see how the same company, how each lot varies in concentrations. And lastly, we'd use an auto sampler HPLC instrument because we had to inject our samples by hand every 30 minutes, and by using an auto sampler, we're able to do other stuff while this is going on, and also it eliminates human error, so it's more accurate for results.
So in conclusion, we dissolved multivitamin tablets in conditions similar to human body. 3 samples of each type of multivitamin were run through HPLC to determine the mass of niacin and riboflavin, which have effects depending if it's too much or too little. And overall, we found that there was a little bit more riboflavin, but it doesn't really matter, and niacin was pretty accurate. So what we did could lead to a more effective verification method of the vitamins, and also hopefully more accurate labels in the future.
So we'd like to thank ECU Summer Ventures and Mr. Sean Moore for funding us for this project, and Dr. Carter, David Farrell, and Alyssa Jackson for helping us and guiding us through this project. And we'd like to thank Dr. Jack Pender and Dr. Keith Holmes for allowing us to use their dissolution apparatus, and Dr. William Allen and Dr. Colin Burns for lending us the HPLC device. And finally, Dr. Brian Love for providing us with the organic chemicals needed for our experiment.
So is there any questions before we conclude on the experiment? Yes, sir.
Well, I guess the sample size is way too small to make many conclusions, but it looks like, based on what you've said, that the manufacturers pay a whole lot more attention to the amount of niacin in their product.
Yes.
Because of the concerns that you mentioned. How do they control the amount of niacin and the amount of riboflavin that they have in their multivitamins?
I think it's generally based in the manufacturing of the product. When they manufacture it, they have to have the certain amounts of niacin and riboflavin in there. The FDA does not regulate the production of vitamins. They only regulate it after it's on the shelf. So if someone has, if someone gets really sick after the product's on the shelf, then the FDA will step in and see how the vitamin companies are making their vitamins.
So perhaps the manufacturers test during the manufacturing process more for the niacin than to do the riboflavin?
Yeah, probably.
And
I think they use a similar method as we did, using HPLC and dissolution.
And then also the riboflavin, since there's not as much adverse effects if there's an overdose, often vitamin companies will put more in the vitamin to ensure the labeled amount is met, because there's not a problem if there's too much for you.
Okay, thank you.
You're welcome. Yes, Elizabeth.
Did y'all look into the possibility that another vitamin could have been colluding with the riboflavin and giving you exaggerated results?
Yeah, it could have been if because we try to run through the HPLC to get the individual peaks, but because riboflavin has a poor solubility, it was actually really good that it had such a good absorption rate. So there could have been another peak under that came out at the exact same time that could have caused higher riboflavin amounts than expected.
Future testing will be able to figure it out.
Any other questions?
Thank
Thank
you
you
guys.
very much.